that answer. Okay? All right, next we're going to talk about reaction mechanisms. Most of these reactions don't just occur on the fly. They have steps to them. So it's how the reaction occurs. Something is formed, it's not that stable, and then you eventually get to the final product. So we've been doing in chemistry lots of balancing equations during the entire year. But it doesn't tell you how it occurs. I mean, we know that plants use photosynthesis to capture and store light energy. We can say we have carbon dioxide and water and we make sugars and oxygen. That's very simplistic. We don't really know what happens in between the sun hitting the leaves of the tree and this photosynthesis reaction occurring. There must be other things going on in the process. So we have something called elementary reaction. That's when your reactants are converted to products in a single step. So if we were to draw this with an activation energy, it would look something like this. So we have our reactants here, we have products here, and then we have our activated complex here. That's just an elementary reaction. Most reactions, on the other hand, have intermediate steps. So we might have something like this, and then like that, and then we have our final products. So we've got an intermediate here, all right? So all these different steps is what we call the reaction mechanism. And I said the intermediate is in between. It's kind of that little well that I showed you after each step. So how is that different than our activated complex that we've talked about before? All right, let me look at that a little bit for you. So if we look at our picture again, we can go up to the top of the hill. So there's our activated complex up here, but our intermediate is where the X is. Then we have another activated complex, okay? And this is our product. And these were our reactants, all right? So activated complex, and this is our intermediate. Okay, intermediates aren't part of your final balanced chemical equation. Now here's a real complicated one. All right, so we basically, at the top of each of these peaks, we have activated complexes, as I showed you, but then we have intermediates at each of these wells along the way. Well, how do these, think about what happens. In a mountain stage of the Tour de France, a rider includes a series of peaks. What does the rider have to do to get back up those hills? They have to give more energy. Okay, so it's an activation energy needed in a chemical reaction. But when they ride down, they may get into a valley and they're at an intermediate state until the end of the race. Okay, this is important. Rate determining steps. Okay, a rate determining step is the one step that is slower than all the others. This determines how fast the reaction occurs. The slowest step will determine or limit the rate of the overall reaction. So here we have a reaction. We have N2O, one of the nitrogen oxides, nitrous oxide, forming nitrogen gas, and elemental oxygen. It's not O2, it's just elemental oxygen. Then another molecule of N2O reacts with that to form N2 and O2. And so then we add up both sides of the equation, and what happens in this equation is that since oxygens are on opposite sides, they get crossed out. So we bring the N2O's down. We got 2 of them. We bring the N2's down and O2. Because these get canceled out, it's only the O2 that remains. So that's the net equation. This then would be our intermediary. Okay? So in this reaction, we have the oxygens as our intermediate. So we also know from experimental results that the first step is the slow step. Okay, so that's our rate determining step. So if you want to increase how fast it's going, you have to make sure that first step is increased by some method. Okay, so I'm going to give this question to you on Educanon. I have a mechanism. I want you to tell me which of the choices is an intermediate. So I'll be back in a second. I'm going to turn off the tape now and answer the question. Okay, did you get A? I hope so. That's your intermediates for this question because you have 2A here and 2A here. Now, we didn't put 2A in front of that because we don't need to put that if it's a coefficient when we're just saying what it is. Okay. If it was A2, of course, we would have had to have, or B2, we would have to have the subscripts. But since A is the compound, then that's all we have to put there. So it's not necessary for us to do that. All right, let's summarize. Take a look at these. These are the things we talked about today, and check them out. Here's some definitions that make sure you know. And that's it. Talk to you later. Bye.